So the next topic that I want to talk about is this combining ratios, and what I think he's getting at here, if I can look through and maybe find one that has to do with it. Combining ratios, right? So we're going to be talking about, we're going to be talking about, I'm so tired. We're going to be talking about how we know how many elements are going to be present in a product, right? There's a really easy way to do this, and that's what makes it fun. I don't think he's expecting us to do anything with a non-metal and a non-metal, so I'm not going to talk about that, but if you are interested, again, feel free to send me a message and let me know. Yeah. Okay, I was just reading through this, I was like, what is he talking about there? But yes, so let's talk about that. So, combining ratios. This has to do with our last video, combining ration. Oh my goodness. Okay, that's to do with the last video because we're going to be talking a lot about ions here, right? So just as a review, what an ion is it is a positive or negatively charged atom or element. Right, we'll write element / compound. Yeah, that's good. Element / compound, because there's ionic compounds. Right, so when we look at something like sodium, it's going to bear a charge of +1. Again, how you know it can do that is because in order to get to its octet, it needs to lose 1 electron, right? And then if we look at something like chlorine, it has a charge of -1 because in order to reach its happy octet, it needs to gain 1 electron, right? So here's the cool thing, right? So when they combine together, as we know, it's going to make sodium chloride. But how do we know how many sodium elements there are and how many chlorine? So all you have to do is you have to cross them. Cross these charges, and that gives you the number, right? So it's literally just going to be NaCl, because you don't write any numbers if it's just one element, right? So let's do an example of something that would have more than one. So let's do, I don't want to do lithium. Let's look at the periodic table. We'll do beryllium, right? So we'll do beryllium phosphide. Okay, so beryllium would have a charge of +2 because it is a metal and it is going to be losing electrons, and it's also easier for it to lose electrons, however you want to think of it. And in order to reach its happy octet, it needs to lose 2 electrons. So it's going to be +2. And then looking over at phosphorus, it's a non-metal, it's more likely to gain those electrons, so it's going to gain 1, 2, 3 electrons in order to reach its happy octet. So -3, right? So we get B, E, P, crossing these charges, we are going to get a result of BE3, P2. And that is the answer when those two combined. So, really the main thing that you have to know here is find out the ion, and then 2, you just cross the charges. Right, so that's basically all you have to do for this, right? So let's look at something where we're gonna be dealing with an ionic compound. So an ionic compound is a compound with a charge. So I'll do an example of some. We'll do chlorite, I think it's chlorite. This has a charge of -1. Hydroxide has a charge of -1. Right, so we'll use this in an example, right? So let's do, trying to think of a good one that we could use. I don't want to use beryllium again, so let's use calcium. This is actually a thing. Calcium plus OH. You treat this like one element, so this whole thing bears a charge of -1, and this thing, calcium over here, will bear a charge of +2. When you have CaOH, you're going to cross the charges. This becomes 1, and this becomes 2. And because it is an ionic compound, you do have to put it in parentheses, so Ca OH2. And the parentheses just basically tell us, like, this thing's by itself, these two are combined together, so it's an ionic compound, so it's going to be separate. But if this has only one of them, you don't have to put parentheses, but that would be the answer for that. So that's just an example of one with an ionic compound. Alright, let's see. I believe that is kind of all that we have to talk about, but I'm also going to talk about how you can find out the charge of certain things. So I'm going to look through the examples that we had on here, because we had one that was kind of tough. Oh, there we go. Okay. SO4. This was one that I know tripped up a lot of classmates, so we're going to talk about it. So, we're going to find out what the charge of S is going to be, right? We know that the charge of oxygen is always going to be -2. So that's something that we can confirm for every single time, right? This can have a charge of something that's not -2, but this is always going to be -2. So we want the overall charge to be equal to the charge of the first thing plus the charge of the second thing. So the overall charge here is 2, is equal to charge of the 1, so we don't know the first one's charge, so we're just going to write x, plus the charge of the second one, which is going to be -2. But you also have to remember that there is 4 oxygens, so we're going to do -2 times 4. So -2 is equal to x plus 8. And then we add this onto here. So sulfur is going to have a charge of, let's see, we do +8, we do +8. That is going to give us 6. So the charge of this is going to be +6. Let's do another example of those, because those are kind of fun. Let's look at, let's look up a ionic compound. List. Alright, so let's look at nitrate. Nitrate's a fun one. Actually, no, I want to do one that has... Yeah, we'll do dichromate. Yeah, we'll do dichromate. That one will be fun. So, Cr2, I think it's O7, is dichromate? Yes, dichromate. And then it's going to bear a charge of, oh my goodness. Okay, it's going to bear a charge of -2. So we're going to do the same thing. We want the overall to be equal to the charge combination of the charge of 1 plus charge of 2. Keep forgetting letters whenever I do this. So the overall charge is -2, which is going to be equal to the charge of 1. So there's 2 of 1. So we're going to do 2x plus the charge of this, which will be -2 times 7. And then also, you might be wondering, like, how do you know that this is going to be positive and how this is going to be negative? The first one is always positive when we're talking about a metal and a non-metal, and the second one's always negative. So that's just like something to keep in mind as you go through these. We're really only talking about ionic stuff right now. We haven't really gone through much of, covalent bonding, but yeah, that's just to keep in mind. Okay, so we get -2 is equal to 2x minus 14. We're going to add 14, and we're going to add 14. So we're going to get 12 is equal to 2x. X is equal to 6. So chromium will have a charge of +6. A singular chromium will have a charge of +6. We could also say that Cr2 will have a charge of +12. That's another thing that you could say there. So those would be our answers there. I believe that is all I wanted to talk about in this video. But yeah, so that is it for that. I think in the next one we are going to go over some more of I don't know. Oh, we're gonna go over atomic mass and everything and how to calculate that. So see you in the next one.